Good morning. My name is Shuhei Tanaka, Kyoto University. So it's a great honor for me to speak to you today. Today I take the suit because this room temperature is a little bit low. So this picture is Lake Shore. So I planted this aquatic plant 20 years ago by myself. As a result, many plastic bottles now accumulated in this year. I can say that this plastic bottle come within these 20 years. So this is a lead shoot, so aquatic plant shoot. This is this component is a cellulose, therefore so it will be decomposed by the microorganism. But this PET bottle, so nobody knows the environmental fate of these PET bottles. Therefore, so I started this research work. So there are many plastic in the world. So that plastic decomposed to the small. So less than 5 millimeter, we call the microplastic. So we'd like to know how much microplastic are there in the water environment. So where the microplastic are generated, and what size, and where they exist. To know it is very important. So this already informed, but 1950 we started to use the plastic very much. So rapidly the increase of the plastic usage. Therefore, so we need to pay attention more about how to manage the plastic now. So the water layer, so already including the microplastic, so this observed already because the plastic becomes very small. Since 2009, so rapidly the increase of the number of the papers. In these 10 years, the total is more than 2,000 papers so related with the microplastic. In the second keyword, so the blue shows the second keyword, so selected is the marine. This means that about 70% of the research focus on the marine in this field. So I often carried out the survey in the ocean and the lake, and I focus on the urban watersheds. So by using the plankton net, so we can get a sample like this. That the mesh size is very important. Ordinarily, the researcher in the ocean use about 300 micrometers mesh size. This is a reason. So this is a result by using the 300 micrometers plankton net. So we can observe the microplastic, the surface of this water. At the same place, I use the 100 micrometers mesh size. As a result, I get these green waters. Because so between the 300 to the 100 micrometer, there are many phytoplankton and the zooplankton like this. As a result, so this plankton is just a matrix to analyze the microplastic. We need to consider how to remove this plankton by using the many methods. That is our scope. Now, so fortunately, we can analyze 10 micrometers microplastic in the water environment. So this is one of the pretreatment procedure. So to remove the organic matter, we use hydrogen peroxide, and in order to remove the inorganic matter by using the NAI we use. Then we remain this plankton net, on the plankton net there is a sample that we can analyze by microscope and FTIR. So microscope, so we can measure the shape and long axis diameter and the short axis diameter like this. But to know the component, so this is a microplastic or the cellulose or the wood or some ion, so we need to use FTIR. So by using this instrument, so we can get this red color spectrum. So this blue color shows the polyethylene, polypropylene, polystyrene, so from the library. So therefore, every sample, so we need to check that is a plastic or not by using this method. So I observed the polypropylene in the Lake Beaver. And this blue one, so the surface area is very high. And some of the microplastics, the shape is very sharp. As a result, the injuries inside of the fish and so on. And this is a polystyrene. So we often observe the polystyrene from the surface water like this. So this is an overall of the microplastic survey in the surface water. We consider the green one is from the artificial, artificial so grass. And so we call that this is microbeads. So this is a result of the microplastic. In the surface water, we get many microplastic in the mouth of the river. Therefore, so we consider the source is urban watershed, I think. So we observe the 26 kind of the microplastic from the Osaka Bay and Lake Beaver. The top three is the polyethylene, polypropylene, and the polystyrene. But we observe the 24 kind of the plastic from the sediment, and only the 8 kind of the plastic from the surface water. This means the most part of the plastic go to the sediment. So this figure shows the relationship between the diameter of the microplastic and the pieces of the microplastic. As the diameter becomes small, the number rapidly increases. This means that we need to focus on more small size of the microplastic. So let's move to the focus. Let's move to the. I'd like to focus on the facial wash. So in the facial wash, there are many the microplastic. Now the our sample is delivered for you. So because we call this microplastic so primary microplastic. The manufacturer makes a very small plastic like this. So in the 2016, we analyzed the facial scrub. So from the facial scrub, I get this picture. White one and the blue one, all are plastics. Especially some blue one or circle one, so we call the microbeads. That amount is very huge. For example, so in the one product, that number is from the 8,000 to 1.8 million. Many the plastic discharged to the wastewater treatment plant. So this is the one point. So the manufacturer understand input the microplastic in the facial scrub, but customer don't know including this kind of the plastic in the facial scrub. That is a very big reason. So this shows the average diameter of the microplastic in the facial scrub. That diameter is about smaller than 300 micrometer. This means the ordinary researcher in the ocean catches bigger than 300 micrometer. This means so they didn't catch this kind of the microplastic from the facial scrub. So in order to analyze the micropollutant, so adsorb the surface on the microplastic, so we catch more than 1,000 microplastic pieces by ourselves, and I separate it in the component and the diameter like this. So this is one of the results. So this figure shows the relationship between the log KOW and micropollutant contamination ratio. So fluor compound and the PAHs we analyze. So some chlorinated PAHs, so that contamination rate is about 5 million. 5 million times higher than the micropollutant in the surface water. This means that the microplastic adsorb quite a huge of the micropollutant like this, especially the hydrophobic functions micropollutant, so easy to adsorb on the surface of the microplastic. So I often focus on the urban watershed. Therefore, so today I'd like to introduce the result of the behavior in the wastewater treatment process like this. Because from the household, we discharge many microplastic every day. The wastewater treatment plant can remove the microplastic or not. We'd like to know it. this is one of the results. So this axis shows the process of the water treatment. This axis shows the microplastic concentration. The total influence that level is about 1,000 pieces per cubic meter. But we focus on the bigger than 100 micrometer this. And by the wastewater treatment process, we can remove so much as a result in the effluent, so less than 1 pieces per cubic meter. This means now that our wastewater treatment system can remove the bigger than 100 micrometers microplastic. But we don't know the more smaller size. Therefore, so we now install the micro FTR and the micro FTR with the FPA. So this one can analyze the 1.1 micrometers plastic. This is one of the results of the influence of the microplastic. So this axis shows the particle size of the microplastic. Y-axis shows the microplastic concentration. We are surprised because so smaller than 100 micrometer every day, we obtained quite a huge microplastic, so more than 100,000 pieces. And this is a microplastic concentration in the effluent. Bigger than 100 micrometer, we can remove it, but smaller than 100 micrometer, so some microplastic remaining. As a result, 1 cubic meter, we discharge 30,000 pieces per cubic meter we discharge every day. So I calculated in the Lake Biwa. Lake Biwa is the biggest lake in Japan, so provides tap water to the Kyoto city. So one day, so daily loading of the microplastic, the 10 micrometer size, is this wastewater treatment plant about 8 billion and 7 billion, and so huge number of the microplastic, the small, just a 10 micrometer size one, we discharge to the water environment like this. As a result, we observe the very small microplastic in the sediment of the Osaka Bay. So this size is about 30 micrometer. This is from the synthetic natural rubber. The car industry so discharge this kind of the rubbers every day. And we observe the microfiber from the sediment of the river mouth. You know that our clothes so consist of the polyester. So polyester difficult to decompose in the natural environment. As a result, so we observe the many microfibers from the natural environment now. Then I showed the concentration level of the microplastic in the surface water in the Osaka Bay. When the size of the microplastic becomes small, that number becomes huge rapidly. This means the wastewater treatment plant didn't remove this size of the microplastic. Then we analyze the microplastic in the digestion tube in the Anchovy in the Osaka Bay. So we compare that concentration level with the surface water. As a result, more than 3,000 times concentrated occurred in the digestion tube of the digestion tube of the anchovy. So some researchers focus on the coral. So Professor Okubo applied exposure of very small microplastic, 3 micrometers one, to the coral in the laboratory. As a result, the coral uptakes the many microplastic. But that concentration level is quite really high, more than 20,000 microsquares per 4 microliters. But we don't know this high concentration now there is in the natural environment or not, because there are many matrix. We need to start to analyze how to analyze the very small size of the microplastic in the real environment. So Professor Okubo says she checks the microplastic size from the 3 micrometer, 6 micrometer, and 11 micrometer. This figure shows the uptake, daily uptake. So coral uptakes the small size of the microplastic compared with the 11 micrometers microplastic. But this shows the discharge. So 11 micrometers size of the microplastic discharge from the coral very much. This means, so coral focus on the very small size of the plastic. Therefore, we should know more the small size of the plastic in the environment. So Japan is in the Asia area. This picture shows the Vietnam. So in the Asia area, so many the plastic garbage discharge like this. So when we analyze the surface concentration of the microplastic in the surface water, sometimes so more than 1,000 times or 10,000 times higher than the Japanese result. We need to pay attention more to the Asian area, I think. But there is one countermeasure I'd like to propose. So this is a membrane bioreactor system. So this shows a conventional wastewater treatment system. We use the aeration zone. But after the aeration zone, we can install the membrane system. So that membrane's mesh size is from the 0.1 to the 0.4 micrometer. Therefore, so this system can remove the micropollutant of the very small size of the microplastic too. But there is one problem, that the maintenance and operation cost is about twice as high. Therefore, so we need to start to discuss we should install this system in the wastewater treatment plant or not. So, but now nobody knows the microplastic fate. Therefore, after getting some result, we should start to discuss this installation or not. So that's my presentation. Thank you for your kind attention. Thank you.